Hi guys, Patrick here from EngineeringShock.com and electroniclessons.com. This is a video to demonstrate one of my new kits. It's a simple 5V to 12V booster. It can support upwards of 800 milliamps. So 5 volts goes in here, a switching output of 12 volts DC is out here. And what I've got is a 12 volt LED bank. Very bright. It won't illuminate until you have at least 8 volts there. 12 volts is preferred max, and it's very bright. If you've seen my videos before, you might have seen these specific banks several times before. So anyway, what I'm going to do is I'm going to power it on. Very bright, and this is in a lit room. It's just very bright. That's 5 volts. Now if I turn this off and I simply I'll leave the ground connected through the board, but I'll connect 5 volts directly to the bank, unboosted. I'll turn it on, nothing. So I'm just going to show you how to build it. It's a very, very easy kit we're going to go through from scratch. If you put together a kit before, you're not going to have any issues with this. You got your printed circuit board, 100 microhenry inductor, diode, 0.33 micro ceramic capacitor, 0.1 micro ceramic capacitor, LM2577 switcher, 680 microfarad electrolytic capacitor, 2 2K resistors and one 118K resistor, and 2 terminal blocks. So first of all, let's do our resistors. R2 is labeled 2K and R1 is labeled 2.2K. This is incorrect. These are both 2K. So since you get two 2K resistors, place one of them in the R1 slot, which is labeled 2.2K, and R2, which is labeled 2K. Then you take your 18K ohm resistor and place it into the R3 slot, labeled 18K. Since resistors are not polarized, you don't have to worry about placing them the wrong way. So put them in and carefully solder them into place. The L1 slot is labeled 100 UH for 100 microhenries. The inductor looks similar to a resistor, but it's thicker and it's green in color. So the inductor is not polarized either, so place it in, make sure there's no shorts, solder carefully. Next we'll do the capacitor. The C1 slot, located right here, is labeled 0.33U for 0.33 micro. The 0.33 microfarad ceramic capacitor looks like this, and it's labeled 334. So it's not polarized, it can go in either way. Place it into the C1 slot. Solder carefully, make sure there are no shorts. The 0.1 microfarad capacitor at C2, the C2 slot is right here, labeled 0.1U, is this baby labeled 104. It's again it's not polarized. There's no polarity. You can place it in either way. Solder into place. Make sure there's no shorts. Lastly, we've got our 680 microfarad electrolytic capacitor. On the top, you'll see a little plus sign. That indicates that that's where the positive pin of the capacitor should go. For those of you who don't know, on an electrolytic capacitor, there are 2 pins, a long pin and a short pin. The long pin is positive, so make sure you place the long pin in the top slot and the shorter pin in the bottom slot. Solder it into place, make sure there are no shorts. The diode, placed in the D1 slot, you have to place it in a certain way. Notice on the left side from this perspective there's a white line on the footprint. There's also a white line on one side of the diode. Make sure that the white line on the diode lines up with the white line on the footprint. If you turn it around, your circuit will not work. So pay very close attention to that. The terminal blocks have a terminal side, and they've also got a plastic side. You want to make sure that the terminals are facing out, or else you're going to have problems. You want to make sure that they are facing outwards so that you can put your wires in from the side. So put those down flush on the board, solder them, good strong solder joints, no shorts, and then lastly we'll do the LM2577. This one's a little tricky. This is the last step. The LM2577T has kind of an odd pinout. 5 pins side by side. Now if you'll notice on the board, the LM2577 slot has 2 pins in the back, 3 in the front, which means that you have to bend back the back 2 pins and fit it in. So it's hard to demonstrate. Now here's the other thing is, when I designed this library, the library for the LM2577T, I didn't make the holes as big as I could have. So it's going to be very difficult to push it down into the board. Push it down as far as you can, but if it's standing above the board a little bit, it should, it's not a problem. You just have to make sure that the leads are going through to the other side and that you solder carefully without having any shorts. So when I'm done soldering it in, I'll show you what it looks like. Hurrah! We're all done. Looks pretty nice. The LM2577T stands above the board a little bit more than I would have liked, but it looks good. And so now we're going to test it. On the right hand side we have our power inputs. There's a V plus pin on the left and ground on the right. So put 5 volts here, and then we will test to see if we're actually getting 12 volts out. So I've got 5 volts in the input. I'll just have a quick look at it. 5.38 volts at the input, and at the output we have 12.18 volts. It works. Easy to put together, lots of fun. I'll include the schematic in the listing. Thanks for watching, everyone.